All right. Hi there. So who am I? I am Bob. I am the project lead for Wildfly Swarm, which is an exciting open source project based on Wildfly, which is the basis for our JBoss EAP Java application server. I am also the founder of the Drools rule engine. If any of y'all have used our BMRS project, that was mine. I'm a founder of the Code House, which if you're my age was an open source community 600 years ago, it seems. And the founder of TorqueBox, which brought Ruby on Rails to the JVM. And as he said, I am the director of research and prototyping within middleware, which means I get to help direct the people to find cool new things to do in the future. So today, though, one of those cool new things we're going to talk about is microservices. You may have heard a lot about microservices being this new, cool, hipster thing to do. And so we're going to look into these a little bit. Because microservices are cool. They give us some promises that our life's going to be butterflies and ice cream if we do microservices. Some of the promises they give us is that it will help us define the architecture of our systems. Instead of having a big ball of mud that some of our large systems have done in the past, we now have little manageable bits. And all these little manageable bits will have independent release cycles so that they can update this bit while leaving the rest of them as they are. Or we could update this one and leave all these alone. And that way, the real goal of all of this is this last point, to accelerate business velocity. And what that means is that ultimately, we have to help our companies do whatever it is our companies do. If we sell books because we're Amazon, we got to help sell more books. If we sell paint, we got to sell more paint. If we move container ships from one side of the world to the other side of the world, that's what we have to do. That doing software is not what our business is supposed to do, unless you're Red Hat. So we have to help the business accelerate. And that is really the primary reason we want to do microservices, is to help the business adjust to the context that it operates in, the environment around it. But to do this requires discipline, because microservices are not easy. The biggest thing you have to look at is what is called bounded context. And bounded context means that if we're going to build these microservices, if we're going to take our one big app, or we're going to break it into little pieces, we have to define the edges of those pieces. We have the bounds around those pieces. And so every service needs to do one thing. Our app might do 600 things, but a microservice needs to do one thing. We may have 600 microservices, each doing one thing, but each one has to do one thing well. And typically, if it used to be a library in your code, it may now be a service, an explicit microservice. And your service will be a black box, because we've defined the inputs very well, and we've defined the outputs very well, but we don't care what's in the middle. We don't care if it's written in Java. We don't care if it's written in Node.js, or Perl, or Basic. It doesn't matter, as long as it can take inputs and produce outputs, generally over a network. This looks kind of like a library with an API, but now we're doing it over the network with microservices. And part of this is we have to have loose coupling, because if we're going to break our giant app, which lives in a single JVM that is really tightly coupled, right? We're breaking it into 600 little pieces, and they need to be loosely coupled. That means loosely coupled in terms of implementations. I can no longer make an API call from one component to another, because I can't assume it's going to be C on both sides, or Java calling Java, or Pascal calling Pascal. I've got a network connection. I'm doing HTTP or MQTT, and I'm passing JSON or XML around. And also, I have 600 services. I don't know where they all are. They could be running on different machines in different data centers. They could be moving around the globe, follow the sun, as our business moves from daytime over here to daytime in the United States. Our services may be moving around, and we need to be loosely coupled in terms of where they are, because we can no longer assume they're running on the same CPU inside of the same JVM. So this leads us to the idea of Conway's law. So Conway basically says, here's all the words, but we can summarize it in this way, that a monolithic organization produces monolithic software. So if you have an organization that has one giant development staff, and they report to one person, one manager, and you have one specification you're working from, you're going to end up with one application, one big thing. And microservices is not one big thing. Microservices is lots of little things. So how do we get away from a monolithic organization that produces monolithic software to get to a microservices-enabled organization? Well, that leads us to my next point, which is called the two-pizza rule. Jeff Bezos from Amazon.com has coined this rule, which basically says that any meeting you have, you should be able to feed everyone who's at the meeting with 2 pizzas. Generally speaking, that's 8 people. Now, if you're designing a big piece of software, 8 people in a meeting is not going to suffice. You're going to have a lot of people missing the meeting, right? But if you're designing little bits of software, well, now suddenly 8 people, including the developers, the product managers, the QE staff, the guys who are doing documentation, they can all be in that meeting because you're solving a very, very, very small problem. Of course, unless I'm in the meeting, and then there's only 3 people, because I eat a lot of pizza. So, for instance, Red Hat 3 weeks ago at Java 1 announced our involvement, or announced the results of our involvement in the Microprofile initiative. Microprofile is an initiative trying to bring down Java EE to a small enough bits to do microservices. Because Java EE has a lot of stuff in it, right? It has JSF, it has transactions, it has a lot of things that don't necessarily help us with microservices. And it's also missing some things that we need to have in microservices. So Red Hat, along with some other vendors, are collaborating to make Microprofile, which is microservices-centric Java, or enterprise Java. So part of this initiative is to build an example app that uses microservices, something you can get your hands on and play with our implementation, Tommy Tribe's implementation, Pyara's implementation. We're all collaborating on this. But our example of microservices includes these 4 microservices. These are our bounded contexts. We designed an application that models a conference, like today. And so there's a microservice that does nothing but manage sessions, like the title of the session, what time the session's happening. Or no, not the time, but just the title. And then it manages another one that manages the speakers. Hi, I'm Bob. I would be in that microservice. And then one that kind of mixes those together to give us the schedules, right? Because a schedule is actually some sessions mixed with the speakers who are giving them and time. And then another one that manages the attendees and how they voted for the session. Everyone give me 10 stars, thumbs up. So this is kind of how an example of what we mean. We could have written a single WAR file that had all this built into it as a single monolithic app, but instead we have all of these. Independently deployable, independently creatable, testable microservices. Independent is the key here. And they all have well-defined inputs and outputs. And then in front of this is the UI, some React.js UI that talks to each of these and pulls up their data. But also, I had a lot of things there. But when we write apps, right, we always care about security, we care about logging, discovery, especially if I have 600 of them, I got to find them, and monitoring them, because if there's 600 of them running, it's hard to tell if maybe 2 died. I need to keep all 600 alive. I need to make sure they're all healthy. When you have one application, that's easy. It's up, it's down. That's pretty easy to monitor. You solved logging once for the app. But here we have all these services that now have these cross-cutting concerns. And we don't want to make everyone who writes a microservice in our organization solve each of these problems every single time. We want commonality on that. So that's a concern when you're doing microservices. So if I haven't already given you some concerns, here's some more. If in the past 10 or 15 years you try to do SOA, service-oriented architecture, and you failed, you will fail at microservices. Because chances are the reason you failed at SOA is organizational. Because of your company, your development staff was not prepared to work in a truly service-oriented architecture. You were a monolith. And microservices is very similar to SOA architectures. There's differences. We don't have an ESB, an enterprise service bus anymore. But it's very similar, and if you failed at SOA, you're going to fail at microservices. So look inside your organization before you even attempt microservices, because you want to be successful if you go this route. If you're doing microservices, and you have 600 little services with independent release cycles, and you're releasing some of them, all of them, every hour, or every week, or every month, that is not easy. You know, when you have your monolith that you release every 12 or 18 months, you know, you coordinate with your IT staff, you send off emails, you have meetings, and it still takes 90 days to get it deployed to production. You can't do that with microservices. There's too much manual labor involved with that. So there are things, though, that can help solve these problems. Containers is one. And I put it in quotes because I do not just mean Docker. Containers can be Linux containers, such as OCI or Docker, and it can also be Uberjars or FatJars, which is a lower level version of a container. Because really a container is just a way to embody all of the moving bits that are important to you into a single chunk. And the reason we want to do this is because if I have all of these things that are changing, I want to reduce places that other things can change. And by using containers, whether it is Linux containers or Uberjars, you can then ensure that the thing I built and the thing that this guy tested and the thing that this person put into production is the same thing. Because how many times have we had developers who use version 7 of something on their laptop, QE is using version 7.1, but production is using version 6.8? You know, little changes like that can cause problems when you move into deployment. And containers prevent that and make sure that everything is put together and expectations don't change as it flows through your process. And I say flow through a process, and that brings us to what's called CI/CD pipelines. CI, I hope everyone is familiar with, is continuous integration. That's where a developer makes a change, we give it to the CI server, it builds it against everything else to see if I broke the code. I break a lot of code. I like CI, it tells me when I screw up. But then we add CD to it, continuous deployment. Because remember, we're trying to accelerate business velocity. The business analyst decided he needs a change to the code. He needs something there to make the business work better. He sent me a new updated specification. I made the change. Why should we wait 6 months to get it to production? If I've made the change and it didn't break anything, it should go into production now. That's how we accelerate business velocity. And so, if you're deploying continuously, you should be building continuously. And if you're doing microservices, you want to be deploying continuously. For some values of continuously. I know some companies do not want to do a release every 2 hours. I understand that. But you have companies like GitHub. GitHub does something like 200 releases a day. I mean, that is crazy to me. But, you know, they make one little change. They have a big system that makes sure that that change doesn't break anything. And so your risk is very small. It's one little change. Let's push that out into production. Another thing that can help with all this is cloud. Also, it's in quotes because there are lots of clouds. There's public clouds like EC2 and Azure. There's private on-premise clouds. And once you're dealing with cloud, there's infrastructure as a service like EC2. And you can move on up to things like OpenStack or to OpenShift, which gives you different layers of abstraction on top of your cloud to help you solve your problems. And this goes back to if you're deploying all the time, and you're deploying a lot of things all the time, you don't want to be emailing the IT guys to get it done. You don't want to have a production staff that involves humans to get your stuff done. So if you're deploying very, very often, you want to have automation in place. You want it to happen easily. and repeatably, something that makes it so that you have no question that it was done right. And things like OpenShift goes beyond just helping you provision. It helps you deal with things that were the cross-cutting functionality we didn't want everyone to solve every time. Things like discovery and failover and logging and monitoring. So OpenShift gives you these things by putting that layer of abstraction between your applications, your microservices, and your bare metal. It handles discovery because OpenShift launches these things. It puts it out there in production. It knows where it is, so it can tell all your other services where to find it. It knows if they're up or down. It collects all the logs. So OpenShift is very useful when it comes to that. So I've told you a lot of reasons not to write microservices. If you would like to write a microservice, this is how we go about it. God bless you. It starts with a journey of one step. Because right now, you all probably have a monolith in your data center, right? And there's no way you're going to just pull the plug and have a microservices architecture next week, or next month, or a year from now. That's not how it works. I know a lot of people try to sell you a microservices architecture where you got to just go all in to microservices. But you don't have to, and no one realistically is going to. So let's pretend for a moment that we have our monolith. Right here, my app is written in Java and is running on JBoss EAP. That's basically a microservice. It's just really big, but that's the starting point. So we look at this application. And let's say that we find one little bit that we could pull out, something that we can wrap some bounded context around. Maybe it's the pricing engine. Maybe it's the address verification part of our app, some small little bit that two pizza team could figure out, and we pull it out of the app. Right there. So now we have one service. In addition to our app that's slightly smaller. Pulling it out, we figured out how we got to make these things talk across the network. We've defined some well-defined inputs and outputs on both sides of that network connection. But we really haven't changed our infrastructure other than we now have two EAPs, two Java app servers. But we also realize that's 100% harder to manage. We doubled our problems when it comes to production. Okay, but we get our IT staff, they're working on the weekends, and they're willing to deploy this for us now twice as many times. So we do it again, and we create another application or pull another microservice out. And so now our app's getting a little bit smaller, and now we have two microservices, well-defined inputs, well-defined outputs. But now it's 200% harder. We're making problems for ourselves. We're not making our lives easier at this point. Maybe for the developers, but not so much for the ops guys. So then we go crazy. And we end up with this. And our ops guys call us the next day and say, oh my God, LOL, barbecue, ponies. We have a problem now. We have taken architecture that's supposed to make development better, and it's made ops much harder. I spoke to a customer 3 weeks ago at Java 1 who had started this microservices journey. And they managed to pull out about 7 microservices before they realized they did not have enough infrastructure in the form of cloud and OpenShift and those kinds of things underneath to be able to continue forward. They had processes they had to improve before they could continue their journey of microservices. So there's a lot of plumbing that's involved in your processes and your infrastructure before you can take this route. And then I keep going back to OpenShift because this is Red Hat form. But OpenShift and these CI/CD pipelines is what you need to have in place before you get too far down the microservices journey. Because every time someone makes code changes, the ideal situation is the CI server builds it. It goes to the QE system where the full test suite is run to compare it to everything else in the world and make sure everything still works well together. And then maybe we stick it in staging. And then we push it to production. Or maybe we don't push it to production, we push it into a little bit of production. And we do red-blue testing or whatever, where we direct 5% of the traffic to the new one, but 95% of the traffic goes to the old one. And we can actually test our microservice with a production load with a very small risk. Then as it gets better, we jack it up to 50% of the load, and then finally put 100% of the load on the new one. This is what Facebook does when they roll out new features on Facebook. They make it available to a small bit to see how well it's going to fare. And OpenShift also handles keeping them running, because OpenShift is based on Kubernetes. In Kubernetes, you can say, all right, I want my service, I want to have 3 instances of that running. And OpenShift will make sure there's always 3 running. If it falls over, or it explodes, or an asteroid hits the data center, Kubernetes will bring those back up and make sure they're running. Since OpenShift put these services where it put them, we can then discover them. Because back in our big graph where we had 5 microservices, they need to talk to each other. They're not running independent islands. They are a mesh. But we don't want them to really know where each other are. So they can ask OpenShift, where's my neighbor? Where's this guy I need to talk to? And they can communicate that way. OpenShift gathers up all of your logs from all of these services that are running and puts them into a console where you can view them. Because if I have 600 services running, and maybe I have 20 instances of each, that's a lot of log files, particularly for Java, because Java people like to log. And most of those logs are ignorable. They're not meaningful, right? It's just, hi, I did something. I don't care about those. I want to see the exceptions. And OpenShift makes it easy to gather up all those meaningless log statements and sift through and find the meaningful log statements. It deals with monitoring, because maybe having my microservice up isn't enough. But if response time is very, very low, OpenShift can help me know that. So I can launch more instances of it, and I can scale up the one microservice that needs to be scaled. Okay, but now I have 45 or 600 microservices. And looking at our previous image, I kept installing a new EAP every time I had a new microservice. And if you know EAP, it supports all of Java EE. That's a lot of specs. That's things like JPA and JMS and JSF and who knows what else. And remember, my microservice is small. It's only doing a few little things. It's not doing much at all, and several of my microservices may not need JPA. Very few, if any, might need JMS. Maybe none of them need transactions. So why am I installing EAP, which supports everything, for all of my little services that don't need all of that? That's why we have much smaller operating systems that we stick inside of Docker containers, because we don't need everything there. We just need just enough. So we'll go back to my introduction, the project that I'm leading, called Wildfly Swarm. We refer to it as Just Enough App Server. So if you're a Java developer and you're deploying WAR files already, and you realize that, well, my WAR file or my EAR file is only using a small subset of Java EE, I could maybe benefit from Wildfly Swarm, because then I get just enough of the app server, and I also get it as an Uberjar, a Java container, not a Linux container, but a Java container. And what Wildfly Swarm does is it takes bits of Wildfly or EAP from the product side and pulls it apart and glues it to your application, just the bits that you need, and then makes it a single thing that can run through your pipeline. As this thing can be tested, and the same thing can be deployed, just like a Linux container works, but at the lower level of Java. And since we're talking about pipelines, we're moving things across the network, right? I move it from my laptop to the CI server, from the CI server to QE, to staging, to production. I don't want to be pushing several hundred megs around. I want to push as small as I can across this network. Because, 200 megs doesn't sound large, but do that every hour with 600 microservices, you're going to saturate your network at some point with these things. And so by making it smaller, you have less burden on your network. And also, smaller gives you a smaller footprint, not just in size of the thing, but as far as attack surface for bugs or insecure issues or security issues. That if there's nothing in there that could be attacked, then it's safer, right? If there's a bug in JPA that gives somebody root access, but you don't need JPA, well, we'll just take that out. So I say it allows you to take things out or only add the things you need. And while we support microprofile, as I mentioned earlier, which is mostly JAX-RS and CDI at this point, Wildfly Swarm actually supports whatever it is you need out of the entirety of Java EE. So if you only need JAX-RS, we will glue JAX-RS onto your app and send it on its way. If you need JPA, that's great. If you need Batch or JSF, that's also great. We have a surprising number of people who use Wildfly Swarm with JSF. I have never seen anyone use JFS in 5 years, but people still do it. Wildfly Swarm, though, also tries to address other issues that come up when you're writing microservices. We make it easy to put Jalakia in every single microservice you produce. Jalakia is a way to access JMX over HTTP and REST. We make it easy to consume and use the Netflix OSX stack. The Netflix components allow us to do client-side load balancing between microservices. It allows us to handle failovers. When we have 600 microservices and one calls another, which calls another, which calls another, sometimes those don't work. Sometimes one is down or the network is broken. And we don't want to fail the whole application just because we lost a link in there. And the Netflix stack allows us to do graceful fallbacks when one of the microservices is unreachable or has lost its mind and is not giving us the right answers. We also do integration with Keycloak, which as the product is called Red Hat SSO, single sign-on, which allows us to do security from end to end through multiple invocations of microservices. Red Hat SSO lets you do OAuth, you sign in, you get a cryptographically secure token, which gets passed along, giving you not only the identification of the original requester, but also giving you information such as which roles he has, so access control. And then we also make it easy to take your APIs that you've produced and marked up with special annotations and produce Swagger output from that. Swagger is nice because it gives you a human-readable console that you can go and play with an API through our browser. Because it's notoriously hard to play with JSON APIs through Chrome, right? It gives you a form, though, where you can paste stuff in. You can see what the endpoints are. And that helps with the development of APIs. So we still end up with this picture with Wildfly Swarm, but everything's a little bit lighter weight because it's no longer running on top of EAP. And I love EAP. EAP is great. But once you get to the point where you don't need EAP, Wildfly Swarm, I believe, is the place to go. And one thing to notice in this diagram is that all these services exist, and all these services were created by two teams, or two pizza teams. And so that means each of these services is low risk. And this gets back to our organizational issue, is that we're now building for replaceability, not for reusability. And so like if we have this, and we like our system, but service number 4 is not performant, since we are microservices, we can rewrite it, because that wasn't much risk in writing it the first time. If we decide we need to change the language for service number 4, instead of using Java, this needs to be written in Go or Node.js, we can do that. We don't have to retool the entire system. So we can just replace single services as necessary when we discover that they might be a bottleneck or might be better written in some other language, or just need to be rewritten with new knowledge and new experience. So that's it, right on the money on time. So thank you very much. If you would like to talk, I'm around.